Everyone, this is Preston, and I am going to be showing you one way of traversing a binary search tree as implemented in one way in JavaScript. So just to show you the setup here, we have a binary search tree that has been defined already. It's a class constructor that we are making here. And then at the very bottom here, we have our class that is the nodes that we are going to be adding to this tree itself. And then down here is an example just for testing. So in this example, what we want to do is we want to we want to get this output, as you can see. We want to pass in no matter what numbers into this binary search tree. We want that's already going to be placing them in the right spots in the binary search tree. And then for this final method that we are creating, we want to traverse it in an in-order traversal. And we want to basically, this is testing if we are succeeding in our in-order traversal. And each time we are calling a callback function. That's what this one is here. And then we are adding those values, pushing those values into this empty array, and then returning them. That's what we want there. So to get started, we want to check if our current node value we want to call the callback on our current node's value. So at its simplest form, a binary search tree will have at least one node. So we will call that callback function on our current node. So this referring to the constructor function object, this dot value, it's the value of the binary search that's within that node that we have added into the binary search tree in the very beginning of our example. So we're going to call that callback function on this dot value, so that the binary search tree's parent node's value, the current node's value. So how do we go to the left or to the right? Well, in order to go left, we would go this dot left. That is going to refer to the as defined in our constructor function. This dot left originally is null, but as we insert something, we're going to insert a new value, in this case nodes, binary node, into the left value. So here we go. This dot left refers to that left node of the parent node, which is this. So so that's how we get to 1 to the left. But how do we go 2 to the left? Well, we go this dot left, right? But we don't know whether or not there is a left node of the left node. We don't know if there is a right node of the left node of the left node. That would be in that case. So we need to use recursion here, right? So how do we do that? It seems extremely complicated, and it is, but the code will be quite short and simple. In this case, what we are doing is determining if the left node exists. So if this dot left, that determines whether or not if it does exist, then it's going to be truthy. If there is no left node, when we first defined our constructor function, the left node was null. So if it doesn't exist, then that left node, or this dot left will return null. So therefore it will be falsy. So this block will never run. So if we do have a left node, then we want to call that. We want to use this same method on what? We want to use that same method on this dot left. So we want to go this dot left dot traverse and passing in that callback function. So in this case, we have taken care of the left direction, right? So this dot left is going to evaluate to true if we do have something to the left. Therefore, we are going to go this dot left dot traverse, so calling again this this method, and then passing in callback func, which is the one that we are the function that we want to call on all the nodes in our tree. Then after we have evaluated everything on the left, then we are going to process the node's value itself. And from there, we are going to then process the right. This should be fairly simple. It should just be copying and pasting the left and then changing it to right. So if this dot right, meaning if we do have a right node, because remember we have defined this dot right to be null in the very beginning. If we do have a right node, then we are going to say this dot right dot traverse, and this is again the recursive a recursive case, passing in callback callback func. So therefore, if we go to the right and there is a node there, then we are going to take that node, call traverse with the callback function passed into it on that right node. And this would make sense that this would work one step down, but it should work as many steps down as we need to go, because if we go just one step down, then this dot left is now going to be this, correct? So this is now going to be referring to this dot left. So if you're just one step down, then this dot left does not evaluate to true, because this dot left is null at this point, because we only have one child of the parent. And the callback function is going to be called on with this dot value passed in, so the node's value passed in. So this is the only case in which we're actually going to be calling the callback function. These are just cases where we are traversing over the array or the tree and then calling the traverse method with callback func passed in. So yeah, there you go. If you want to look at how this works in the Chrome debugger, let's look at that. I've pasted all the code that we had in there in the Chrome debugger, and then I put the debugger right here in that traverse method. So let's start that. So to begin with, we are going to be stepping over here, and as you can see, vals is empty because vals was empty to begin with. And then we are going to go over this dot left. So array of nums is 15. So this dot left of, again, the current value is 50. Yes, we are going to have a left. And then we are going to step over, adding that 5 to the array. And as you can see, we're adding the items in order into that array. And there you go. So there you have it. Recursive. That's tail recursion on a binary search tree. Thank you for watching.